Okay, for this section of notes, guys, we're going to talk about 1-8, perimeter, circumference, and area, okay? So, a polygon is a closed plane figure made up of at least 3 segments. So, here's a version of a polygon right there. You have at least 3 sides, and then it is closed. Here's another one right here. One that a lot of people don't automatically assume is a polygon is something that looks like this. But does it have at least 3 segments? Yes. Is it closed? Yes. Therefore, it is still a polygon. It's just a specific type we're going to talk about here in a minute, all right? So, let's talk about our most common polygon names, all right? When you look at this chart, the only ones that you really need to pay attention to are the first names on here, okay? So, a 3-sided figure is a triangle. A 4-sided figure is a quadrilateral. A 5-sided figure we will call a pentagon. A 6-sided figure we will call a hexagon. 7-sided figure is a heptagon. 8-sided figure is an octagon. A 9-sided figure is a nonagon. A 10-sided figure is a decagon. An 11-sided figure, even though we very rarely use it, you still need to know it, is a hendecagon. And a 12-sided figure is a dodecagon, all right? Now, you see where it has this ... here. That stands for anything after 12. So anything after 12 we're going to call an n-gon. N is what the number of sides is. So let's say it has 13. We would call that a 13-gon. If it has 20, we would call it a 20-gon. If it has 80, we would call it an 80-gon. If it had 1 million sides, we would call it a 1 million-gon, all right? So let's talk about diagonals. Diagonals are segments that connect 2 non-consecutive vertices. So if I'm starting at this vertice and I travel down to this vertice, those are 2 non-consecutive vertices. What that means is they're not right beside each other. So an example of a consecutive vertice would be going from this one to this one. That right there would not be considered a diagonal because they are consecutive vertices. That would be a side of the figure, okay? So that's the difference between a side and the diagonals. And you can have more than one diagonal coming out of every vertice if need be. Like this one has 2 for each vertice, all right? 2 types of polygons. First one is a convex polygon. A convex polygon has no diagonals with points outside of the polygon. So if you look at this figure, every single diagonal in this figure here has the inside of the figure. One way to think about it is if you look at every vertice that this thing has, every vertice actually points outward, all right? If it points outward, that's another way of thinking convex, all right? Then we have a concave polygon. This is where we have at least one diagonal that is outside of the polygon. For this one, it would be this diagonal here, all right? That diagonal is actually outside of the polygon because these 2 sides point in the direction of in. If you have a vertex that points into the figure, that's what concaved is going to be. One way to think about this is think of a cave. A cave goes into the side of the mountain, so if it's going into the mountain, then it would be a concave polygon, all right? Let's talk about perimeter, circumference, and area. The first shape we're going to talk about is a square. Now, perimeter, we don't really use the formulas for that much because you guys should know perimeter is just simply adding up all the sides. So however long every side is, we just add it together. That gives us the perimeter. You do need to know the area formula for a square, which is s side squared. You could also not use that one and just use the one for a rectangle. So for the rectangle here, you have a base and a height. A square and a rectangle are essentially the same formula. It's just in a square, it has all 4 sides the same, so you don't have to worry about base and height part. Again, perimeter, don't worry about too much because that's just adding all the sides together, okay? Then we have a triangle. A triangle, again, perimeter, A plus B plus C. We don't really need that because it's just adding up all the sides. But you do need to know this formula. 1/2 base times height is for area. Most people forget the 1/2 there, okay? So don't forget that. And then lastly, we have our circle formulas. For circles, you actually have 2 formulas for circumference. Circumference is the distance around, so it's pretty much like the perimeter of a circle. You have pi times diameter and 2 pi r. We'll be using both of those. Eventually throughout the year, you'll see me more use 2 pi r just because that's one that you'll see me stick with. You can pick which one you want to use. It's usually depending on what they give you. And then, of course, you have your area formula, which is pi r squared. All right? So let's talk about this first problem here. It says the Botany Club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. How much edging material will they need? So they're talking about edging. When we talk about edging, we need to think about that as being our perimeter. Now, they want it around the outside of the path, not on the inside of the path. They want it on the outside of the path. So we need to figure out what each dimension is for this. We need to figure out the width and the height of it, or the base and the height, however you want to say that. So let's go ahead and figure out the base. It tells us from this point to this point that it's 16 feet. Problem is, we have extras over here and here that we need to figure out as well. If you look up here, it tells you that the width of this walkway is 4 feet. So that's like saying there's an extra 4 feet here and an extra 4 feet here. If we add all of that together, 16, 4, and 4, we would get a total of 24 feet. All right? And then we also got to do the same thing on this side. From this whole distance, they're telling us is 22 feet. Then we also have a 4 here and a 4 down here, which gives us a total of 30 feet for that distance. So now that we have all of those measurements, we can now figure out the perimeter of this. You got to think of it, guys, is if it's a rectangle, we know that this side is 24, then we know the top is 24, right? And if we know the right side is 30, then the left side is also 30. So we can now figure out the dimensions of this perimeter by saying we take 30 plus 24 plus 30 plus 24. We just add up all the sides, right? Once you've done that, you should have gotten a total of a perimeter of 108 feet. All right? For our next one here, we're going to talk about circumference, all right? So for the circumference of a circle, notice it says in terms of pi here. We're going to talk about what that means on the first problem, but then they also want us to go ahead and do this problem to the nearest 10. So it's like 2 problems in one. So let's do the first one, first 2 together here. It says they want us to find the circumference in terms of pi and to the nearest 10th of circle M. Notice over here at circle M, this is a diameter. So for this case, I'm going to use the circumference formula that says pi times diameter, okay? So circumference equals pi times the diameter is 15. Now, we just need to clean this up a little bit. To clean it up, all we're going to do is write the 15 in front. So the circumference equals 15 pi inches. Now, they said in terms of pi. In terms of pi is a great thing because you actually stop right there. What it means is this pi right here, we're not going to multiply in. We're going to leave it as 15 pi inches. Makes your life a lot easier, okay? And then the next one we're going to do, guys, we're also going to do this in rounded to the nearest 10th. Whenever you do this, you guys have gotten in the habit of saying, well, pi is 3.14. Yeah, that is an approximation of pi. We're not actually going to use that in this class often unless it tells us to. What we're going to do is we're going to say, we're going to put 15 in our calculator. We're going to hit the second button right here. And then we're going to hit the caret key button right here. All right. Once you've done that, it gives you 15 pi in your calculator. You hit enter, and it gives you an answer of 47.1 when you round to the nearest 10th, and that would still be in inches. All right. So make sure that you know both of those ways, and if you see it in terms of pi, you leave it here. If you see it rounded to the nearest 10th, it goes here. All right. So let's do B together as well. In this case, you notice that they give us a radius because it's only half of the circle, right? So we're going to use circumference equals 2 pi r. What we're going to use for the radius in this case is 4 because that's the radius of the figure. So 2 pi times 4. All we need to do is clean this up a little bit by combining this 2 and 4 here, and it's multiplication, right? So we're going to say that circumference equals 8 pi centimeters. Now, that's left in terms of pi, so we don't need to go any further for that part. But the second part of this does want us to do it rounded to the nearest 10th, so we just take 8 pi in our calculator, hit enter, and we get that the circumference equals 25.1 centimeters. All right? So what I want you to do right now is go ahead and pause the video here, try A and B at the bottom, and then we will do them together. All right, now that you've had an answer to try A and B, let's go ahead and solve them also. So for A, it says, what is the circumference of a circle with a radius of 24 meters in terms of pi? So for that one, they've given us a radius, so for circumference, I'm going to use the formula 2 pi r. And in place of the radius, I'm going to put 24 because that is the radius. So circumference equals 2 times 24 is 48 pi meters. Now, because it said to leave your answer in terms of pi, I'm actually done right there. You don't have to do any more work. Easy peasy lemon squeezy, right? So, for B here, it says, what is the circumference of a circle with a diameter of 24 rounded to the nearest 10? In this case, I'm going to use the formula pi times diameter, which is pi times 24. Now, it says to do this one to the nearest tenth. So what I need to do is I need to use my calculator, and I'm going to put 24 second pi, if it was turned on, 24 second pi, and we get a total of 75.39. Now, when we round this to the nearest tenth, your answer would actually be 75.4 meters, all right? Because we round it to the nearest tenth. Remember that 9 rounds that 3 up, all right? All right. For our next problem here, it says, what is the perimeter of triangle EFG? To find the perimeter of a triangle, we just have to add up all the sides. Well, if I'm over here, you don't want to use the distance formula 3 times for this problem. We only have to actually use it once. So we're just going to find the distance by saying we go over 1, 2, 3, 4, 5, and 6. So the length of that side is 6, all right? Now we can do the same thing for this up down. We can go up 1, 2, 3, 4, 5, 6, 7, 8. Now that we have those 2 dimensions, we just need to find the third one. To find the third one, we need to figure out the distance. Now we're finding the distance of GE, all right? So we need to know those 2 points, which would be this point and this point. And if you recall from earlier, our distance formula is the square root of x minus x squared plus y minus y squared. So we just have to take whatever we get for G and E and plug that in. My 2 x's, we have a negative 3 and we have a positive 3. So we're at the square root of negative 3 minus 3 squared plus, and then my 2 y's are negative 2 and 6. So negative 2 minus 6 squared. All right? So now we just need to clean that up a little bit. Negative 3 minus 3 is a negative 6. And remember to keep it inside the parenthesis to make it a little bit easier. Negative 2 minus 6 is negative 8 squared. So once we've done that, we can go ahead and say that negative 6 squared is 36. And then 8 squared is 64. And then from there, clean that up a little bit. 36 plus 64 is the square root of 100. And then the square root of 100 is 10. So we know that this side is 10. Now that we have that, we just simply add all of it together. 6 plus 8 plus 10 tells us that the perimeter of this would equal 24 units. All right? So at this point, go ahead and pause the video and then go ahead and try problem 3 on your own. If you look over here, there's a graph on the next page that you can use as a reference as well. All right, now that you've had a chance to go ahead and graph this problem and try it, the reason we try to graph things, guys, is it makes it a little bit easier on these problems. So like this one, do you want to use the distance formula 4 times or 1 time? Most people want to use it 1 time. So if we graph it, we don't always have to use the distance formula because you can count 1, 2, 3, 4 here, so that length is 4. 1, 2, 3, 4 here. There's another 4. 1, 2, 3, 4, 5, 6, 7 here. Now, the only one we have to use the distance for is M to L. Now, L is there and M is here, so we need to just use the distance formula for those 2 points, all right? So we get the square root of our 2 x's again are 1 and negative 3. So 1 minus negative 3 squared plus, and then our 2 y's are 4 minus 1 squared, all right? So if we do 1 minus negative 3, that's actually saying 1 plus 3, so we would get 4 squared. And then 4 minus 1 is going to be 3 squared. 4 squared, we end up with 16, plus 3 squared is 9, so we get the square root of 25. If we take the square root of 25, we get an answer of 5. So we know that this length right here is now 5. So if we want to find the perimeter, we just add up all of our sides, which are 4 plus 4 plus 7 plus 5. If we add all of that together, we get a total of 20 units. Now, a lot of people wonder why we're using the word units instead of inches because we're on a graph. We don't actually know what the unit of measurement is at this current situation, so we just always say units when it's on a graph, right? All right, for the next question, it says you are designing a rectangular, or you're designing a poster that will be 3 yards wide by 8 feet high. How much paper do you need to make the poster? So they're asking for this in square feet, which should tell you, 1, we need to convert everything to make sure it's in feet. 2, we're also doing area. So let's draw I'll use the same rectangle that's over there. They know that this part is going to be 3 yards, and they know that this part is going to be 8 feet. So the problem is we can't find an area unless they're both in the same. So what we need to do first is we need to convert this 3 yards into feet. How do we do that? So we take 3 yards, and for every 1 yard, there's 3 feet. So we're going to multiply that by 3. And that'll tell us exactly how many feet are in 3 yards. And that would give us 9 feet. All right? So we can now get rid of this 3 yards up here and put 9 feet in. Now, if I want to find the area of a rectangle, if you remember we went over this earlier, it's area equals base times height. So in this case, the base of this would be 9, because it's at the top. You could use top or bottom for base. And then the height of it would be 8. When we multiply that together, our area equals 72 feet squared. Now, if you do not mark it as feet squared, it is technically considered wrong. So make sure you know area is always measured in units squared. So whatever unit you're using, you put units squared with it, okay? All right, let's do area of a circle now. Area of a circle is very easy. You just use the formula that they give you. That formula is area equals pi radius squared. Now, I want you guys to notice that it does say in terms of pi, so we do not need to multiply in that pi by the end of this, okay? So, if you notice over here, they've actually given us a diameter of 16. So if our diameter equals 16, then we know our radius would be half of that, which is 8. So area equals pi 8 squared. So to clean this up a little bit, we just got to figure out what 8 squared is. When we do that, 8 squared would give us 64. Now, you could do that in your calculator by hitting 64, and then just hitting the squared button, which is right here, and that'll get you your answer. Or not 64 squared, sorry, 8 squared, and get 64. So you get 64 pi meters squared, and that is your answer. You do not have to go any further because it did say to leave your answer in terms of pi. So at this point, I want you guys to go ahead and pause it. Go ahead and try question 5 here. Answer A, B, and C. Okay, hopefully you've had a chance to do A, B, and C here. For A, if you did the area in terms of pi, you would have gotten, you start with your formula, which is pi, which is the radius squared. The diameter is 14, the radius is 7 squared. So A equals 49 pi feet squared. All right. For B, we just take that answer and we plug it into our calculator. So we would use 49 second caret key to get us the pi, and we would get 153.9 feet squared. Part C here says, which approximation of pi did you use? Hopefully, you use the pi button, but if you use 3.14, your answer would be off. This is the reason we always use the pi button unless they tell us otherwise. If you did 49 times 3.14, your answer would be slightly different. You would have had probably rounded to the same answer, but you notice there's a difference between those two. So we always want to use the pi button unless they tell us otherwise. So for we would use the pi button, all right? Area addition postulate, guys, this is where we take one area, add it to another area, and it gives us the whole area. So the area of a region is the sum of the area of its non-overlapping parts. So let's say we find the area of this to be 20, the area of this to be 30. You would know the entire area would equal 50 units squared, all right? Because you would just add those two things together. That's all area addition postulate is. The problem is you're going to have to find the area sometimes. So we have a figure that looks something like this. We need to split this into 3 different shapes. You can split it in different ways, but I'm going to do it this way. Now, they tell us that this has 2 tick marks here, which means that this one has 2, this one's also 9, right? then anything where we see that has a 3 because it has the same marking, right? So 3's go on all of these. So we need to figure out the area of each piece. Let's start with this small figure first, which is a square. It has 3 and 3. So if I want to find the area of that, I just do 3 times 3, which would give us 9. Then we're going to find the area of the slightly larger, or the smaller rectangle, the slightly larger figure. For that one, we know that the 3 goes here. The problem is we need to figure out what goes up top. Well, think of it this way. If this whole thing is 9 and 3 of it's taken right here, then this has to be 6. So if we want to find the area of that, we would do 6 times 3. When we take 6 times 3, that would give us 18. And then we need to find the last one, the area of the larger one. We know the bottom's 9. We know that is 3. When we take 9 and multiply it by 3, that would give us 27. So if we want to find the area of all of this, we just take those 3 numbers, add them together, and you would get 54 centimeters squared. So D would be your answer. All right? For this one right here, I want you guys to go ahead and pause it, try this problem. Keep in mind, guys, when you do this, you could easily form a triangle. That's going to be your easiest. So what I would say is you need to draw an imaginary line right here and go ahead and try it. Once you're done, hit resume, and then we'll go over it together. All right, now that you've had a chance to do this, hopefully you got the right answer. You need to think of this, guys. If this is 4 right here, then we know that this is 4 and this is 4, right? So we need to figure out the dimensions of everything. Let's start with the easiest figure first, which is that rectangle, right? We know that this side is 4. We know the bottom is 12. So we could easily find the area of that. So it would just be 4 times 12, which would be what? 48. And that would be feet squared, right? So from here, we need to now figure out the area of this triangle. Well, we know this dimension over here is 4, and then we know that now we need to figure out the bottom piece, right? Because that's the base of it. So think of it this way. If this piece right here is 4, and the whole thing is 12, we just take 12 and subtract 4. When we take 12 and subtract that 4, we would get 8. So if I want to find the area of a triangle, this is the one formula we haven't really talked about. It's 1/2 of the base times the height. So area equals 1/2 of 8 times 4. So you could do this piece by piece, or you could plug it into your calculator all at one time. I will tell you, if you're going to use your calculator, always try to use 0.5 in place of 1/2, and then parenthesis 8, parenthesis 4, and that would give you a total of 16 feet squared. So all we need to do to figure out our whole answer is we take 48 and we add 16 to it. If we do that, we get our final answer to be 64 feet squared. If you have any questions, feel free to ask us. Hopefully you understood it, and see you in class.